Thank you very much. Welcome, everyone. My name is Elizabeth Hodgson, and I'm a regional vegetable specialist with Cornell Cooperative Extension. I'm excited for you to join our workshop today in the 8-part Spray Safe, Spray Well series that will take place now through the end of March. This workshop was made possible thanks to support from a Northeast Extension Risk Management Education grant. And this workshop is being recorded, and a link to the recordings in both English and Spanish will be shared when they are available. If you have any questions during the presentation today, please write them in the chat box, and we will read them out loud to the presenters during our question and answer period. If time allows, we may also be able to ask participants to unmute to ask questions. But for now, please make sure that your microphone is muted during the presentations. At the end of the program, we will launch poll questions. These are optional, but they provide us with helpful feedback on our program. It's my pleasure to introduce our speakers today, Davis Blasini and Ricardo Orellana from the Produce Safety Alliance. They are Spanish language extension educators, and they'll be discussing safe and effective sanitizer use in washing and packing areas for produce. And so with that, I'll turn it over to them. Thank you for joining us today.
Muchas gracias, Elizabeth.
Thank you so much, Elizabeth, for having invited us. It's really a pleasure to be here with you today. And today we're gonna give this presentation. I'm actually going to share screens, and we're gonna really expand on the ideas and concepts that have to do with the safe use of sanitizers in wash and packs. As Elizabeth mentioned, me and my colleague Ricardo Orellana, we are associates of the Alliance-PSA, the Produce Safety Alliance, as you say in English. And before we continue and expand on this presentation, I'd like to present you to what our Alliance does through our national level trainings. Our Alliance is a collaboration between Cornell University, the Administration of Food and Drug Administration, the FDA in its acronym, and the Department of Agriculture of the United States. Its acronym is USDA. So this association was made to be able to prepare growers of fresh produce to follow the prerequisites and the regulations. And it's important to say that this act and these regulations are one of the 7 regulations within the FSMA Act. FSMA is the acronym. And from 2015, our director has created a curriculum that creates this course to be able to train the growers in this alliance. And so we do this labor of training growers around this, these regulations of how to take care of the fresh produce. We want to repeat that this act, these regulations is pretty new from 2011, and there was movement in that time to keep educating growers on this new law. And this has been our work from 2015 to now. Ricardo and I have been with the Alliance for 1.5 years, and our work is to expand all of these training tools, this knowledge about the regulations and of good practices to Spanish-speaking growers in the United States. We also want to say that we also give trainings in Latin America. And Lala and Elizabeth referred to this. We want to bring this language justice, if we want to call it that, to be able to bring all these tools, all this training to the Spanish language. It's very important. As we know, it's really important in the area of agriculture, both in the US and because of the large volume of produce that we consume that's grown in Latin America. So that's why Spanish is so important. So again, Elizabeth, thank you so much for the invitation. Thank you for the program of commercial horticulture in the east of New York to Cornell Cooperative Extension. We have been participating in these webinars, and it's such a good initiative. So we're coming here with so much enthusiasm and very excited to present. So thank you so much. So now I will officially start the presentation that we have today. As we're speaking about today, the sanitizers while washing and packing produce. Why is this important? So this is the moment that we start speaking about the disease that can be caused while consuming fresh produce, in this case, fresh produce. And the causes of these diseases are these pathogen microorganisms that are very important in this industry of fresh produce because they've been associated to many diseases that have repeated themselves throughout the years. So that's where the importance of the federal government take this theme and this topic. And that's why they created this new law in 2011 to try to diminish the spread of disease caused by the food. So this is a list. It's not an exhaustive list, but these are the three main groups of pathogenic microorganisms that we can see. We divided it in three: bacteria, viruses, and parasites. If you've seen news in the recent years, maybe you recognize some of these names because they've really echoed in the news for causing disease, death, throughout the diseases that these microorganisms cause. Salmonella, E. coli, Listeria monocytogenes in the case of bacteria. Now, when we move on to viruses, it's the norovirus. This one happens pretty frequently. Hepatitis A. And in the case of parasites, Giardia and Cryptosporidium. And these are the ones that have really repeated themselves and caused a lot of problems in the industry of fresh produce. Because of that, is that we have this need to take precautions to reduce the chances that these microorganisms affect producers and the products themselves. So here we are going to talk about these pathogens and how these pathogens can propagate in the post-harvest moments. One of the vectors that we have identified in the outbreak of disease is the water as a vector of pathogens in agricultural operations. So here we're going to expand the concept. You're going to see it in a couple of moments of cross-contamination. And this is the contamination that comes from water and is transported from the water to the fresh produce. Another source is contaminated surfaces, tools, and equipment. So here is, we see the cross-contamination concept again, because these surfaces can pass pathogens from one product to another. And in this way, we can spread the problem in an agricultural operation. The other source is a poorly maintained building, because this can allow pests to enter. And as we know, pests can transmit these pathogens. So that can be a way of introducing pathogens into an impact area in an agricultural produce operation. So it can be roofs, coolers, and plumbing that is in poor condition. So here we see Hysteria, and this bacteria grows in refrigerated areas where in low temperatures actually are good for this bacteria. So in refrigerated areas, if they're not well maintained, if there are leaks or condensation, we can see that leak can transfer Listeria from the roof or the walls to the fresh produce. So this is one of the ways that Listeria has been able to arrive and contaminate fresh produce. And that's where we've seen outbreaks of disease caused by these pathogens. And that's why it is fundamental to get into prevention. It's really the best way to deal with these problems is prevention, first and foremost. And it's really important to emphasize, we're training all the time in English, in Spanish. We need to emphasize that the fresh produce are often consumed raw. So if they are not going through a cooking process, and people sometimes don't even wash them well, these pathogens, once they get to this produce, they are going to get to the consumers. And that is where the problems start in these outbreaks of disease. Another thing it's important to mention and to have really present as growers is that once these products are contaminated, it's really hard to eliminate the contamination. I like to refer to these pictures that I'm sharing here in this slide because, as you can see, I'm referencing the here a melon or the surface of a strawberry, and you can see that it's porous. These surfaces are porous. So once they are contaminated, it's really hard to eliminate or extract the contamination from the surface of these products. It's important to take this into account in our agricultural operations. And here I'm using again the picture to illustrate what I'm referring to. When we talk about lettuce, you can see that in these spaces between leaves, that those are places where pathogens can stay through soil, through water, and that's how they get to the consumer. So it is complicated. And that's why prevention is the best tool, the primary tool to use in these operations. And another picture that I like to show here is the wash and pack. Generally, agricultural operations, they really have optimal conditions for bacterial growth because we see these types of spaces and corners where the pathogens can really establish themselves and grow.
I'm gonna
And
be in
so
the.
through cross-contamination, we can see that the contamination can get to fresh produce. And now we're going to expand on the main part of our presentation, which is sanitizers and pesticides. So we're going to start with a definition. What is a pesticide? You can see here that it's any substance or mixture intended for preventing, destroying, repelling, or mitigating a pest. But in the specific case of fresh produce, we talk about antimicrobial pesticides because our objective is to eliminate and destroy the growth of microorganisms that are damaging these pathogens that I was referring to. Here, when we talk about pesticides in the United States, we really have to talk about EPA labeling requirements. Why? Because EPA, the Environmental Protection Agency of the United States, EPA is the acronym, this is the organism that is leading the regulation of these products through the Federal Act, Federal Insecticide, Fungicide, and Rodenticide Act that has the acronym FIFRA. This is the main law that leads the registering, the sale, the use of pesticides in the US. Pesticides have to be registered and have to contain an EPA number. Why? Here is good to refer to the fact that if a product is processed, it's possible for it to have some sanitizing substances that are also regulated by an EPA. So nevertheless, the majority of producers, use sanitizers that are regulated by the EPA. So I want to highlight here the importance of that number, that label, that EPA label. So before going to market, these sanitizers, these pesticides, go through a verification process by the EPA agency. In this process, the EPA determines how effective these products are given what they offer, what they say they offer, and also the damaging effect that they can have on people and on the environment. They make sure that that is said clearly. So that's why it's important to use products that have EPA labeling.
The treatment of water after harvesting. Here we're talking about how we use the type of disinfectants, and we're going to talk about cross-contamination. That is one of the main objectives between water and the products and the surfaces. And this is where we're going to expand farther ahead. But here, this idea of defining the water and inside the pulp of the fresh product and the filtration of the pathogens that are going to be in the water that are going to affect the pulp inside of the products. And something that is also very important, another benefit of the use of these disinfectants is the reduction of pathogens of plants, plant-based pathogens, pathogens that are not going to cause illnesses to the humans, but it does affect the life and rot of the shelf life of the produce. The time that the produce is going to be available for the consumer and the quality of the product. That is also going to be better if we use this type of sanitizer. So this is another benefit of the use of the water post-harvest. Here we're going to define what are the more general uses that we find in the different types of operations in the United States. It varies a lot from one state to another and from one state to another. But here we bring two categories that we consider principal. The water of one step. So single water use, the water only touches the product once, or the water uses it more than once. So here I'm gonna use the pictures that I have at the bottom, the water that is only single pass water at the left, or the batch water that recirculates converter or the dunk tank. In both cases, it is important to mention that they can prevent the buildup of microorganisms. Here, like we mentioned at the beginning in this presentation, we trained many people, or we talk a lot about the norms for the fresh products. Here, I want to refer in this image that we talk about this norm doesn't require treatment of the water, post-harvest water. It doesn't need treatment, but it is recommended. Like you can see, we made an emphasis that the water, that this type of water that touches more than one product at the same time that is deposited in these tanks, there is a higher probability of contamination. So it is recommended that you use disinfectants. And to show you the concept, we created this illustration. So you can see the idea that how the cross-contamination can happen in this type of tanks. How you can see here on the left, we illustrated apples in black that are not contaminated, and only one apple that is contaminated with a pathogen in red. And like you can see here, and we put it in the tank to wash, and in this tank, this water does not have a disinfectant. And then what we see ahead is now the little red dots that you see everywhere, the pathogens survive and they expand with the water. At the end, we see that now the whole water has pathogens, but also the products acquire those pathogens, and we have a higher risk of contamination. The scenario that we see on the right with the disinfectant, we treat the water before washing the product. And once we wash the product and it has enough disinfectant, what is important is what we say, follow the instructions of the disinfectants to all the details, because that is how we know that they're going to work and that we're using them how they're supposed to work. So when that water has enough disinfectant, we see that the pathogens do not propagate, they don't survive. Then we have that the low contamination risk, it's lower in the water that we did on the, compared to the one that we did on the left. So that's why it's so important that we talk about the benefits of the use of sanitizers in the water that we're going to use in post-harvest. So here we go back to emphasizing the idea that the water, the disinfectant in the water doesn't have the intention to wash the product like you saw, but is to prevent the cross-contamination. So it is important that this product has to be labeled and that you follow the steps, the instructions of the label of this products. And that we use products that have a previous use, that if we want to use a disinfectant in the water, it has to say that it's for that specific use. If we want to use a disinfectant for the contact with the fruits and vegetables, we have to look for a disinfectant that clearly is labeled that is for that use. And we're also going to mention farther ahead some tools that can help you, that can help farmers to find or decide and select a disinfectant for your operations, for your agricultural operations. Another thing that is very important to analyze before deciding what type of disinfectant you want to use and when is the variables that are in the water that can affect the use of the disinfectants. And this changes a lot depending on the region and even within the states, depending on what part of the state you're in. And we're going to talk first of the quality of the beginning of the water, the first quality of the water, very important, because that way we're going to start with a good foot ahead at the time of preventing any type of contamination because of the water. So the pH comes from what comes in the hydrogen, the power of the hydrogen is a measurement of the level of acidity or alkalinity of a substance. Is number 1 is very high acidic, and then that starts to go up until it goes to 7. Then we say that a solution is neutral, there is not one or another. And then once we start to go up 7, 8, 9, 10 to the 14, we start to say that the substance is more alkaline. A substance that is 14 is alkaline, and that could be dangerous. So this measurement is very important to us for us to know the pH that the water has when we're going to use disinfectants, because the pH can impact highly the efficiency of the different products that are antimicrobial that we're going to use. And we have to monitor. So we can also check the turbidity of the water, which can also affect us, like chlorine, the difference between temperatures as well, between the pulp of the product and the water can also create infiltration of the product into the fruit or vegetable that we're using. Turbidity, this is the level of organic matter that is suspended in the water. You can see it right here on the picture. We have water that has a lot of turbidity, that is brown, that it's like darker. And then we have water on the left that is more crystal-like, that is clearer. This is important because it's important to determine or monitor at the time of using disinfectants, because this level of turbidity can affect the effectiveness of the disinfectants. And then also you can also use that when do you need to change the water. And we have seen this in a lot of operations of carrots, for example, where you can use the turbidity level to determine when it is the right moment to change the water when you're washing your products. And here I expand some more around the quality of water, the criteria of the initial quality of the water for the harvest and post-harvest. And I'm going to refer in the Alliance-PSA about the resources that are here between the norms of the fresh local agricultural products. And we talk about this norm that it requires that the activities of post-harvest, that the water shouldn't have E. coli or anything like that detected in the water. So we gotta make sure that the water is the cleaner that it can be, so it can be useful for us in post-harvest. So here we give some examples of this norm that it refers of activities of the water post and prior to harvest when you are having fresh produce. So I make use to the sentence that is covered by the norm, that there is certain products that are regulated by the norms of the care of the agricultural products. So we specify that it is important for these products that are covered and regulated under these rules of the care of agricultural products. When there is direct contact of this, the surface of the product, when you're touching eyes or when you're washing with the hands. So we got to clean that water clean. If we have water with pathogens and we wash the hands with those pathogens, then we're going to have cross-contamination between the hands of the workers and then also the agricultural products. So this norm of taking care of the fresh produce also requires that the surface water is not untreated. And we're not supposed to use untreated water and when I'm talking about untreated surface, I'm talking about water from rivers, lakes, or reserves, whichever water it's in the landscape. This water can have dangers of having pathogens compared to a water that has come from a municipality or a well. Here, we're going to talk a little bit more about the concept of pH that can change the efficiency of the sanitizers, especially talking about chlorine. The chlorine works really well in a pH between 6 and 8.5 in a pH scale. And here we have different ways in which you can monitor the pH. Here there's a picture, there's this test strips. It's very economic and it's very accessible and easy that we can monitor the pH in the water post-harvest. And the pH can change with chlorine. So it is important to mention that chlorine is a substance that is alkaline, that they put in water, and that they put in water to change the pH of the water. So it's very important that when you make this type of treatments, monitor that the water is between 6 and 8.5 in the pH scale. There is minerals that you can find naturally in the water in the United States, and this also can change the pH of the water. So it is very important to also mention that the pH of water can be adjusted using substances that are alkaline or acidic. It is important that you understand that what we refer in English, they're food grade, to be able to operate with food, so you can use them in this type of operations. And with this, I'm going to pass the microphone to Ricardo. Are you ready? Yes, Davis, gracias. Thank you. I'm going to continue, like Davis mentioned, with the discussion around the variables that can affect the quality of the initial quality of the water. There's two things. One is the initial quality of the water that you use in the packaging and in the post-harvest. That should be the quality of sanitation that he mentioned, free of E. coli in a test of 100 milliliters. And the second part is how the agricultural workers can keep that quality of the water in the way that we maintain that initial quality, and that the application of a disinfectant is a strategy that can save lives. In the point of view of the norm of the quality of the fresh products, the use of a disinfectant is not required. Nevertheless, if the farm workers decide to use a disinfectant to maintain the initial quality of the water and to prevent cross-contamination, so the norm, yes, requires certain regulations of the few that Davies was talking to us, and I'm going to continue telling you about. The next variable is temperature. And like Davis already mentioned, this is very important because the difference in temperatures between the fresh agricultural product covered by the norm and the water temperature can create conditions for infiltration. And how does this happen? When the fresh agricultural product is harvested in the fields, they can have a higher temperature of the water temperature. And that generates conditions for the water to be able to infiltrate the product, the produce, with those physical characteristics. Or because there's bruises or it's been bumped, so the water can come in and introduce the microorganisms inside of the produce, the pathogens. And exists many factors, a couple factors. One is the size of the tank, the depth, the how much water you have in it, the time that the product is in it. That the fresh product is too deep, then there can be more pressure, and that facilitates the infiltration. And then also the time that the product it's submerged inside the water. In general, this depends in the nature of the product. For some agricultural products, the difference between temperature can be higher and for others lower. It is important that the farmers have technical information, scientific information of this product, so you can figure out what are the conditions that infiltration can happen. In this sense, it is important that you know that there is general rules that talks 10 degrees Fahrenheit that can help infiltration. So waters that are lower, let's say 10 degrees Fahrenheit, that can create conditions for infiltration. If the water is contaminated and you have these conditions that we're talking about, that microorganisms can infiltrate the fresh products and cause contamination. The Alliance has created tools that explain, it is in English and in Spanish, and this video helps us in a quick way, in a simple language to explain the agricultural workers. I'm going to ask Davis if you can look for the link for the video and share it in the chat. And if not, I can share with you at the end of the presentation. If you have any questions, please feel free to ask any questions in the chat. And Davis is going to be reading the chat. Also, our compa, our friend, is going to be helping us here. And she is also part of the team of the Alliance, where we have worked out this presentation, and they have a lot of ideas. A lot of ideas came from Donna and our director as well. So the temperature, you have to monitor the temperature to minimize the risk of the potential of infiltration. And what that means is, like Davis mentioned, in products that are based out of chlorine, the temperature can also affect the efficiency of these products, including the ones that are known as disinfectants. And then we're gonna pass to the next slide.
This variable about turbidity is also really important because in general, turbidity refers to the loss of transparency and clarity in the water that is deposited in a tank where fresh produce will be put, well, where they will be washed or where they are cooled in that tank. So turbidity can be used to give producers and growers an idea to monitor, is the clarity being lost? Is it becoming more turbid? Is it becoming darker? This monitoring of the water is really important. And to establish programs to change the water, especially in systems of water. And there are methods to monitor turbidity. I already see a question in the chat. The question is, what is infiltration? So basically, what infiltration is, in simple terms, is the input of water through a product. So water goes through the surface and the skin of the produce. We're washing that produce, we're cooling that produce. So what happens is inside of the product, you create a vacuum, and that way the pathogens come in and contaminate the product from the inside. This happens because of variables in temperature. Like I said, the product can have a higher temperature than the water. So that generates conditions for the water to infiltrate, to come in. That's what infiltration is. This can be very common because agricultural products, when they are harvested out on the field, normally, since they are still breathing, they are at a higher temperature. Normally, that heat from the field is remediated by the growers with water to cool down. But coming back to the turbidity theme, we have themes to monitor turbidity. We also have discosechi, and this disc sechi disc is like a tube. Below it, it has a disc, and it is black and white, and it's measured in milliliters. So producers can see how the water can lose that clarity, that transparency. You can see it in the picture below here in the slide. You can see there different beakers where we can see waters with different levels of clarity. The turbid water could also reduce the effectivity of treatment because some disinfectants, especially those that are based in chlorine, these disinfectants can be absorbed by the organic material. So it can inactivate some of these sanitizers. The turbidity can. So we can use this as a visual aid to establish a program of water changing, especially in systems where we are circulating water. So these programs really depend on what kinds of products are the products that we are washing. Or for example, what types of containers we're using, what type of harvesting container. Does it bring leaves? Does it bring soil? That can get to the water and affect and generate turbidity. Next slide. The monitoring of antimicrobial treatments, including using sanitizers. This is important because any water treatment, including using sanitizers, must be monitored throughout the use of this treatment. This is a regulation. This is a requirement. Each sanitizer will have its specific ways of being monitored, of its levels being monitored. So this is where it's really important to read the label of the sanitizer, because that's where you will see the instructions of how to undergo these treatments. A lot of these products use what Davis was mentioning, is these value systems, so that you can monitor the concentration of the sanitizer, so that you can maintain the effectivity of it and reduce the risk of contamination. If we pass on to the next slide, please. the disinfectants on the surfaces. So this is really important because we're talking about sanitizing. So the important thing to mention is that we should not disinfect a dirty surface, which you will always need to clean that surface. What does this consist of? This consists of removing everything the eyes can see. So cleaning can include sweeping, cleaning tables, washing them, washing the surfaces of contact, the surfaces that will have harvest on them. This cleaning should be always done before the use of sanitizing. After we clean, as you can see here below in this slide, we can see the 4 steps for disinfecting. So after that is when we can apply, like you can see in step 2, in the second image, we can see that we are applying a detergent. After applying this detergent, we are washing and scrubbing that surface to remove all the contamination, all that dirt that we can see on the surface that will touch produce. The detergent that's used in this moment should also have, like Davis said, food grade. It should be food grade detergent, but it also should be labeled as such. So if we want to eliminate grease or we want to eliminate carbohydrates, then we have to be sure that we are using the correct detergent. In the third step, we wash with water. And here it's really important to not use pressure hoses, especially in closed spaces. Why? Because if we do, that contamination, we could spread it even more and even lead it to harvest containers or to storing containers. So after we wash, that we've done that removal of everything we can see is when we disinfect. This is a treatment of a cleaned surface to reduce or eliminate microorganisms with the use of this sanitizer that we have chosen or the product that is right to be used. If we pass on to the next slide, please. How to select a sanitizer. Davis said that the EPA evaluates these preliminary results that have to do with potential toxicity of sanitizers in order to determine their efficacy in eliminating pathogens on specific surfaces. It's speaking of specifically their effects on contact with food. In post-harvest, these sanitizers must be registered. They must be approved for that use by the EPA. Next slide. And here we continue with this theme. All pesticides that are used here in the United States must be registered and must have a registration number, either from the EPA or from the FDA. Although, as I mentioned, the law, FSMA, and especially the product safety rule does not expressly require growers to use a sanitizer that must be labeled by the EPA. So this is a way that we can maintain the safety of the quality of the water. So maintain that level of safety that is required to, for example, workers washing their hands or the washing of the actual fresh produce that are covered by this norm. And so if we can go on to the next slide, the label of the sanitizer should be reviewed before the use of this product. So we have to pay attention to this registration number so that we can appropriately identify it. As we can see down here, this is a label. So you must use this label to know what we can use it for. And we can apply it in surfaces that will be in contact with food. So we have to follow its instructions. And we have to see that it is declared efficient to eliminate pathogens that the pathogens, the specific pathogens that this product is intended to control. This is where we can see the example we were talking about. It is a product, Sanidate, and you can see that the label can have, you know, different, it can have a different, like A, B, or C. So the sublabel A is general use, sublabel B is agricultural use, and sublabel C is aquatic use. You can see here how this relates to the registration number of the EPA. We can see it in the next slide more clearly. So what we can see is the same, but here we see it in Spanish. This is the EPA registration. In this registration, we can see the producing company and the number of registration. This is the number that specifies which product specifically it is. This is, we can see, this is the producer at 7299. This means that this is the company that produces it. And 19 refers to the type of product. In this case, Sanidate 5.0. Next slide. And the message here is to always read the label instructions. You must always follow them because it is the law. You have to use the product for the purpose it was made for. For example, if it's going to have direct contact with fresh produce, you know, a surface that is going to have direct contact with fresh produce, like a table of packaging, you have to use the correct dosage, and the right ppm or any other measure that is indicated. And we have to understand the factors that affect efficacy. In this conversation, we've already talked about temperature, about pH, in some of them sunlight, and how they are affected by organic load, which means by soil, leaves, or any other organic material that could affect the efficacy of the sanitizer. In the Alliance, you know, the team here of the Alliance, we've created this sheet of technical assistance. We have it in English, we have it in Spanish. You can see it here. What it refers to is certain delineations of how producers can be supported to follow these rules. So we have these series of things that are super helpful. For example, why should producers use a sanitizer? It gives you the reasons why. The next part, what information should you review in a label, in a sanitizer label before you use it? Next. The selection of an adequate sanitizer for your operation is important. You know, this is all about what kind of space are you using the sanitizer in. In general, sanitizers that are based in chlorine, these are used a lot because they are not too expensive, they're easy to find, usually they're available, but we have to make sure that that sanitizer is labeled for the use that the producer wants to use it for, not simply that you go to any supermarket and you buy Clorox and then you prepare a solution based on that. Many times those disinfectants are not for use of fresh produce. We have to remember that they could be corrosive, they could be highly reactive, but also there's many options that are non-chlorine based, as you can see in this slide: ozone, peroxyacetic acid, hydrogen peroxide, and other kinds of products that we're going to name a little bit later in an Excel sheet. We will make this available in the website of the Alliance. It is available. Sometimes it's more expensive, but it doesn't necessarily have to be. The producer has to analyze what is it they can use, but there are different also formulations for producers who do organic growing. This is important. You can see certain brands here like Spectrum, Sanidate, but we also have to consider that these agents and agencies that certify will tell you if that product is actually apt to be used for this use, for this type of production. Next slide. And here what we want to show you is an Excel sheet. This sheet also has a video accompanying it. What you can see, this is in English and in Spanish. And this is a sheet that you can see, different products, different labels, what active ingredients it has, and other things that can help you select the right sanitizer. This Excel sheet that has been translated to Spanish by Davis has an instructional video where you as a grower can see step by step how you can use each tool to sanitize. Next.
De operación estándar, por sus siglas en inglés, es el SOP.
Now, the standard operation systems, this is a product that you can see the steps to develop a specific idea. This has different instructions. So if you can do a worker in or out, the standards can be the same or the same procedure. So there, you can hear the different products that we can use in the activity and the market and the time where you can develop these products and how often you need to do this, the registration and why you register. And here we have an example. Examples of standard procedures, standards of the post-harvest water for the monitor and adding monitoring the pH, the water, the temperatures, the thermometers, the sensors, and to remind you that the norm doesn't require the use of cold rooms or cool rooms, but you have to use them in the right way and get to the requirements of the thermometers. So this is to avoid condensation, because condensation can create the space for microorganisms. And this is simply examples of different Excel sheets that you can keep registration, record keeping, to be able to share we're going to share the links of these different record keepings and templates in Spanish and English for record keeping. So you can help us to keep all of the activities, all the requirements. Okay, it is required to have record keeping of the water management, the monitoring, the antimicrobial product use. So you can determine which practices have been useful and if they're working right, and identify certain patterns for your practices. Some of the requirements are required by the law, and also the norms for agricultural products for fresh produce. So some of them is required and some of them are suggested. And here it is the website. And here you can find all the different products, videos. You can find technical assistance, presentations in PowerPoint, Excel sheets, etc. And with this, I don't have more time to continue. There's 1 minute until the end of the presentation assignated for this activity. But if there is some questions, please, I'm here and I would love to answer. And yes, Davis is also here. Thank you for your attention. Ricardo, there is one question here. What are the problems related with the disposal of water, of the chemicals, when we utilize chemicals, when we use disinfectants? What are some of the problems that when we dispose of these residual waters? This is a very interesting question, because especially in the hand washing stations, or when we are talking about the disposal of water where you have used a disinfectant, a sanitizer, because we have to be really careful, for example, with the aquatic life that you can contaminate, where there's water, natural water. For example, where there's bodies of water near where we do our agricultural system, or where you can put in danger the life of the nature around you. We have to think about the environment and try to keep up with as much norms so that way the drainage systems are adequate so you can avoid those problems. We had 2 slides extra to show you about the norms of the washing the fresh products, but because of the time, because we're gonna end the time if we try to export that theme for the complicated, but what we want to do is invite any people that speak Spanish or in English that wants to know more about the norms of taking care of the fresh products. Please take our courses. They are available for people in New York free. And this is something that we can organize and that we're constantly organizing, again, in English and in Spanish. So this is something that if you're all interested, please, we invite you to contact us or to contact Elizabeth because we have information about it. And here I see that Elizabeth put the poll on the chat or up. Yes, we want to say thank you to Elizabeth to consider that this is a very important space for many reasons, a technical space where we can share ideas, but also to be able to support all you producers. All these products learn about the norms that protect fresh produce. We didn't have time when in operation under the norm, but there's a diagram that Davis is gonna look in the chart, show in the chart, and has questions. When does a norm, when does a farm is under the norm, or when is there a farm can apply for an exemption, a qualified exemption? So I would like if Davis will share this. It's a schematic that is easy to follow. And if it's not easy, we can help you and support you in the reading of this. And this is a capacitation that you're able to go through. Thank you.
Well, I think with that, that concludes our program. Thank you so much for attending, and special thanks to the Language Justice team for providing the interpretation. And we hope to see you at our next program.